So here's a response to a question I posted on my channel, and hopefully I'm going to be really nice and concise and quick. So a line is perpendicular to y equals 2x subtract 5 and passes through the point 0, 3. What is its equation? So you've got tools, okay? So the first thing we want to identify is the gradient. Gradient is the number in front of the x, essentially. So we have y equals mx plus c is the general form for a linear equation. And you'll find that in front of the x is our gradient m. And the number part is at the end, that's the y-intercept. So this is really important. For us, it's the 2. So the gradient of that line up there is 2. And the second thing is the relationship between a particular line and its perpendicular line is given that the gradient of the first one multiplied by the gradient of the second one is going to be equal to -1. So that is very useful, and I do remember using that very heavily when I was studying at A-level. Now, this is a while back, and there's a more simple term, I suppose you could say. You could call it the negative reciprocal. So you give you some examples. 7, the negative reciprocal would be -1/7. Like if I just wanted the reciprocal, it's that. But the negative is that. Okay, let's try -8. You can sort of say before me if you want to say. That's going to go to an 1/8. Oh, you say, yeah, well, if it was the reciprocal, it would be 1/-8. But you can have a negative situation because you want the negative reciprocal, so it's going to be positive. What you'll find is that it always turns a positive to a negative and a negative to a positive, and you're going to do the reciprocal. So an 8 goes to an 1/8. And 7/3, for example, will go to -3/7. You get it? You flip it upside down. All right, so that's the negative reciprocal. Now we're going to need that, or we're going to need this relationship, because essentially the gradient of the next number is either going to be found by saying 2 times the second gradient equals -1. Therefore, if we divide both sides by 2, the gradient of the second one is -1/2. Alternatively, if we know that the reciprocal is 2, then the negative reciprocal is -1/2. Same thing, right? We get it to half. So let's say we got our second gradient. The next tool that we're going to want is to find the whole of the equation, right? That's what it says. What's the equation? Now, the equation is m, but it's also plus c. So we found m. So make that really clear that m is -1/2. Let's get rid of that. And we now need to set about finding c. There's 2 ways of doing this. Now, the general formula is usable if you have the gradient and we need a coordinate. Actually, I'm going to go a bit further. It has to be on the line. But the general formula is y subtract y1 equals mx subtract x1. And it's making it look fairly complicated, but it's really useful. So we know what m is already. Okay, I'm just following that same color down. And if we put something into this, we can find the remainder of this equation pretty quickly. So as I said, we've got the gradient, and we need a coordinate on the line. Now it says up here that it passes through 0, 3. So that's great. If it passes through 0, 3, that means that at a certain point, x equals 0 when y equals 3. This will go into our equation along with the gradient, and away we go. y1 is the coordinate. I should probably label this. Give me a second. That 3 is the y coordinate, and that's what the y1 is. The y stays where it is. It just doesn't change. X is x1. Okay, so that's where everything's coming from. We're going to put this into the formula and replace as necessary. So let's get rid of this. The y, as I said, always stays as y, and then the y1 is 3 because that's the x coordinate. And the m was -1/2, and we have x, which stays as it is, but the x1 was the x coordinate there. Let's do a little tidy before rearrange. We got -1/2 x. Because you take away 0, it's not going to do anything, so we're just going to leave it like that. And the general form for an equation is that y is the subject, essentially. So if we, let's do it properly, if we add 3 to both sides, because this is the additive inverse. So it's going to turn it to 0, so we're left with just y. But the right-hand side, all right, so we found the equation of the line, which is perpendicular to y equals 2x minus 5. It passes through 0.03. However, there is a much quicker way of doing this. Because you know that the gradient of this one is 2, it follows quite quickly that the gradient of the other one is negative half. So following the fact that we need those two elements in the y equals mx plus c, we can replace it as we go. So the gradient is negative 1/2 x plus c. Great. We only need to know what plus c is now. And wow, it's actually pretty easy. Remember that plus c is the intercept. Okay, the point where it crosses the y-axis. Okay, right there. What's the coordinate of that point where it crosses the y-axis? All I know for sure is that it's 0 for the x, and then whatever c is going to be our y or whatever. And it's really important to know, because as soon as you know x is 0, that's going to be in line with the y-axis. And so any coordinate, anything that c turns out to be, for example, 7, that is the y-intercept, because that's at 7 now. Or if it was 10, that's 10. That's where it crosses the axis. So if it tells me it goes through 0, 3, that means that this must be 3. And we know it was because we did the calculation over there, but it's just reassuring. If I was given the coordinate 0, 3, I would probably do it this way. If I was given the coordinate 10, 17, I probably have no choice but to do it this way, because I'm not necessarily going to be able to work my way back to the point where it crosses the y-axis based on that. All right, so I think that brings it to a wrap. I hope that was useful. Thanks very much for being a subscriber, for asking for these videos. I like making them. I hope it helps.